All right. Hey, everybody. Thanks for joining us today here at the SF Java Users Group. I'm here to tell you all about Elide, a new framework and runtime built for the polyglot era. My name is Sam. I'm the primary author of Elide. It's all open source. And so what you're going to be seeing today is some demos, some benchmarks, some cool stuff that you can play with on GitHub. A little bit of background about me. I'm a software engineer. I've been an engineer in the Valley for many years. I've spent time in many languages, Python, Java, PHP in some darker days. Now I spend most of my time in Kotlin. We have a company, it's called Elide as well, where we provide dev tools around this polyglot future. And so we also have a build cache called Buildless, which you can check out at less.build. If you use Maven or Gradle or Bazel to build your Java, then you can cache with our system, which plugs into Cloudflare. It's pretty cool. In the meantime, I'd like to thank the SF Java Users Group for having us and Shack15 for hosting us today at their co-working space on the Embarcadero.
Very welcome.
So let's get started. Elide is a framework and it's a runtime. It's a framework in the sense that you can use it like Micronaut or Spring to build a web application. It's a runtime in the sense that you can use it as a binary on your command line, just like you would with Python or Node. Let's talk a little bit about the history of what got us here, why we're building Elide. And I won't spend too much time on this because I think we all know probably a lot of it. We lived it. Rewinding to about 1995, the way that the web worked was pretty simple. There was a client, there was a server. It made a get call for some content. The server returned that. In this timeline here, we're calling that classic SSR. So this model is pretty familiar to the JVM people in the room. And it was a simpler time, you could say, on the web because there wasn't a lot of interactivity. We weren't worried yet about JSON or XHR. Things weren't really API based. It was just a server returning content to a client. And this was amazing for languages like JVM and Ruby and Python. There was an explosion of innovation in these languages at this time. We all got the frameworks that we love today, like Spring and Tornado, all the other ones in each language that birthed the first generation of unicorns. Now, this evolved with the invention of Chrome and a number of other inventions along the way, like XML HTTP request, which gave birth to AJAX and JSON APIs. And now the UI shifted to a place where most of it was rendered in JavaScript. And so this is an architecture called CSR, client-side rendering, or SPA is another name, single page applications. In this architecture, there's a big JavaScript bundle. It sort of takes over rendering for the server. The server returns bare bones HTML with this JavaScript. The JavaScript does the rest. And nowadays with React, Vue, Vite, Angular, whatever the framework of the moment may be, they're typically served from a Java or Python or Ruby app this way, with a big JavaScript bundle that takes over the whole show. Chrome, XHR, and all these things gave birth to a massive explosion of innovation on the JavaScript side. As we all know, there's tons of different options for rendering UI. NPM has a lot of packages that you can pick from. And we've all sort of watched in our own language universes in Python and Ruby and JVM as this white hot engine of innovation kept going and making cool things. There are ways for us to use it, but most of them are messy and involve headaches. Looking ahead, we think this stuff gets a lot simpler. We think that what Node did for the world is great. The lessons it brought to the table are great. The packages and tools it brought to the table are great, but they need to integrate easier with the applications that we build in the JVM and Python and Ruby worlds. In the future, when we're writing apps like this, you'll be able to do more with less because there'll be less overhead in talking between languages. There's no time really anymore to argue about culture wars and the borders between languages. We've already accepted that we need to be able to write JavaScript and Python or JavaScript and Java or whatever it may be to target browsers or to target whatever it is that you need to target. Plus, the JVM is seeing a massive resurgence. Now with JVM 21, there are staple language features that compete with a ton of different modern language features elsewhere in programming. The power of the JVM is clear as a leader in the next 5-10 years. Most of these features, Loom and Panama and so forth, haven't even fully hit yet. And so it's a really exciting time to be a JVM engineer. Just a few more trends to note that are involved here. One is WebAssembly, which is really cool, and it may present an opportunity for a new suite of languages in the browser, like Python and Ruby and so forth, but it's very early. And so while it's sort of part of our work here, and we are watching it closely and anticipating WebAssembly support in different ways, it's not the core of this system. We need something that can work today. GraalVM, language VMs are getting much smarter. They're speaking multiple languages. They're able to compile natively. And this is happening at the same time as developers are sort of choosing that full stack is the way to go, that they're going to keep a full stack suite of skills, that they'll use multiple languages in their application when needed. We see all of these trends as kind of adding up to one thing. And on that note, Elide is a new runtime and framework built for the polyglot era, where using multiple languages together isn't so painful. And especially in backend languages like JVM and Python and Ruby, using things like JavaScript is much easier and more native. So we have a few design goals. Number one is really to make polyglot frictionless, fun, easy, and fast, and to deliver these process innovations for backend languages that we think have been missing for a few years. It's also cloud native from the ground up. It's designed for this cloud era where we're storing secrets externally, logging externally, all sorts of support systems that come into play when your app goes into production. We think there should be first-class support for these things in the runtime because they're always there. You're going to need them. So a bit about our architecture very quick. You'll notice there's a lot from Oracle here. Oracle's awesome, and they make amazing technology. We use a JIT compiler native builder from GraalVM, and the language implementation is provided by GraalVM. And we sort of occupy this space in the center where we provide the APIs and the native language intrinsics that you need to drop an app in. The language VMs that are provided by Graal are amazingly fast, amazingly stable, but they're not equipped with the intrinsics from Node or the intrinsics from, different runtimes that you might need. That's where we come in. We implement those, we benchmark, we test, we provide them to your app, and they behave identically to other runtimes. We take a hard stance here not to invent other APIs. There are enough APIs out there. Each language has their own. They're great. And you probably have your favorites. You should be able to use those. Instead of replacing or creating new ways to set up an HTTP server, we support the popular APIs that you would probably want to use anyway. Okay, so first we're going to look at some command line samples. We're going to look at using Elide as a runtime command line tool. And in this case, Elide's running your code from the command line. So let me switch here to my CLI. So we're going to see some features where we use Elide on the command line, sort of like Node or Python. And to get started, we're just going to run help and see what the available commands are. So here we have Elide. We can run a shell, like an interactive shell. We can join a Discord. We can file a bug right from here. To start, let's check out an interactive shell. By default, JavaScript is already built in. And so that's the first one it gives you. So we can maybe JSON stringify something. So it has JSON, it has some syntax highlighting as well, which is nice in each language that's supported. We can generate a UUID. There's different things we can do here that are standard JavaScript APIs. So the UUID there, for example, is from the Web Crypto API. So that's an example where Elide is supporting web APIs that are well documented and standardized. One more is, for instance, like a URL, right? So we could say new URL. We can ask it for the host. There we go. One thing I'd like to point out here is this right here. And what that's telling us is that the URL object that it gave back is actually a Java object. And here's the package in full path. So that should be familiar to some JVM people like us. This is actually a Java object under the hood. As the author of the URL intrinsic, I can tell you that URL intrinsic is actually powered by Java Net URL. So under the hood here, we're actually using the amazing road-tested high-performance built-ins from the JDK. We're not reinventing anything really here. The URL parsing logic, lots of that stuff is all coming from the JDK. So that's how this runtime can be mature much quicker than, say, one of these newer JavaScript runtimes, which can't pull from the extensive standard libraries supported in Java. So let's take a look also at Python. So let's go ahead and import OS. We can look at some environment. Now, one thing to notice here is it's injecting variables for us. React and other different libraries expect things like node-env. That's made available here. And then these variables here are coming from a .env file. So I have a .env file here in the root of my directory. If you've used Node before, this feature is pretty familiar, where you can put variables in a .env file and those apply to your application at runtime. So one feature that you'll see in our slides later is Elide will load those for you and apply them in all the languages that you enable. Okay, so we've seen a few uses on the command line. Let's take a look at some code and how you would use Elide as a framework. So the first sample we're going to look at is very familiar to us server-side people, which is a totally plain hello world. We're going to have a browser client that requests the root page, and we're going to write back with a 200 OK, and we're just going to say hello Elide. Let me share my IntelliJ here. So here's our sample. Now we've got Kotlin here as our dialect. We've got an object app, and we've got our entry point to our app. We're marking this class as a page, which is named index. Names for pages in Elide can be used to generate links. That's kind of only something that we see as programmers. Down here, we've got an annotation that maps get / to this function. It's a suspend function in Kotlin. What we're demonstrating here is how this can plug in with Micronaut, which supports suspend functions, thankfully. And then here, we've got Kotlin XHTML preparing our response. And so this is pretty simple. Let's take a look at what this looks like. So in this case, Elide really isn't doing much yet, right? But it's a plain sample, and so we're showing how we could use these annotations and different pieces together from Kotlin X and from Micronaut to stitch together sort of a pure server-side application. Okay, let's take a look. If we load localhost 8080, we've got hello Elide. So we've started here with our basic sample. Now we're going to kind of kick it up a notch, and we're going to add some CSS. And in this case, it's server-side CSS. So the client's just going to request /style.css. We're going to build that from the server, similar to what we just did. Now here's our sample this time. And I've got some breakpoints from earlier, but we've got our root page, and Elide gives us this handy alias here to easily embed a style sheet in the page. And so this is sort of the first place where Elide is making an entrance besides the page controller and the page annotation. So here is our style sheet. We've got our URL, and then we're building rules here and values in our styles. This is Kotlin X CSS. The build cache notices you see are from build lists as well. So quick plug there. So let's go to this page. All right. We've got some content. We've got a style sheet here, and we have served our styles. There we go. We get a green page. Now we're going to get a bit more complex, and we're going to include some JavaScript. This is the architecture we were talking about earlier with CSR, where an application is built in JavaScript, it's shipped to the browser, generic HTML, and the JavaScript takes over for rendering. Now, in this sample, we've got our index page. We've seen that. We've got another alias here, this time including a script. We've got our styles still, hasn't changed. Down here, we just reference a module. That's actually coming from Elide's tools in Gradle. We ship a build plugin, which I'll show you here. And so this plugin is saying, we're going to make a server. We have some assets. We have a script. It's called scripts.ui. And we want to build it from this Gradle project here. And this Gradle project builds a simple front end that just says hello. We then embed this in our build, and Elide will take that, embed it in our jar. It'll compress it in different ways ahead of time so that when it comes time to serve this asset, we don't have to compress it at all. We can just send it right back to the browser. So back to our sample here, we can reference that script with just scripts.ui. So the fact that those match up between the build and the server is enough to build our JavaScript and serve it from this endpoint, right? Okay, let's take a look. So Elide's helping compile our Webpack front end here. It's assembling our assets and embedding them in the jar. So at this stage, you can see it's generating an asset graph for us. So it understands the dependencies in the front end assets, and it's embedding that in the jar for us. So click here. Okay. Now it says hello from JavaScript, which was injected from JS. This is starting to show how Elide can help you stitch together an app with your front end assets, and how it can start to kind of take the burden off of all of the coordinative aspect of building those assets, serving them at the right URLs, embedding them at the page in the right URLs. Okay. Now let's do something even cooler. Let's do an SSR sample. So this is the first step where it would be very hard in other frameworks to do this. And that's because we're going to use the power of Gradle VM to actually embed some JavaScript in the server. We're going to execute that JavaScript at a handler. We're going to take the output and we're going to splice it into the page and send it back. So in sort of a hybrid JVM JS app, we're going to include both languages. Okay, so in this sample, we're going to use React. And what's cool about this is React uses this notion of props. If you haven't heard of it before, props are sort of the input properties that go into a render. So if you're familiar with Timeleaf or Jinja, you might hand these engines a map, right, of properties that would be slotted into variables in a render cycle. React is similar in this way. It has this concept of props, and on the front end, props can change. And when props change, things change live on the page. So server side, obviously, there's no animation or anything like that. So our props are sealed. Our props are kind of a data class here from Kotlin with just a name. And we are exposing those to the VM so that they can be accessed reflectively. We prepare those props in our index page here. So similar sort of structure as before. But this time, we call this function inject SSR. And this is kind of where the magic happens. So when this line is called, it's going to prepare our props for us. And then it's going to hand those props into JavaScript, where it's going to run a function to produce some content. That's going to be spliced into the body here. So we can prepare the body cooperatively between the JVM and JavaScript. And then the whole thing is going to be sent back to the client. So one complexity about SSR in this manner is that there's actually two JavaScript targets here. There's the JavaScript target that we send to the client, right, which we had seen before. And you can see that here. But there's also the JavaScript that the server needs to execute. And that actually has to be built differently because it can't use any of the browser APIs, right? It's actually not executing in a browser. It's executing in Gradle. And so Elide is helping us stitch together all the build complexity here that makes that difficult. It's building our JavaScript assets twice. It's producing a configuration that it can use at runtime to load these from the jar assets and reference them. So very quick, before we look at our server here, we'll take a look at the build script. So for an SSR project, we can see it says Elide. We can set a dev mode or production, which gives us compiled minified JavaScript, or we can have our symbols. And here we're saying we're going to have a server and it's going to do SSR with embedded JavaScript. And we want to pull that JavaScript from this project in Gradle. This is helping us build that Gradle project however so it would be built, and it just needs to output JavaScript, right? We can take that, embed it in our application for server-side execution. And then here we're setting some settings for our front-end assets, right? So here we can include a style sheet. We can include a script as we did before. So this is that second script target, by the way, right? We've got the SSR target here and the front-end target. Okay, so this is now running. We'll go take a look. All right, hello, Elide. This was served over hybrid SSR. So if we look at this page, you'll notice now that the full structure is there. So we've got CSS, we've got our script, but then we've got this main root, serving mode SSR, div, strong, hello, Elide v3. This page was served over hybrid SSR. And so we didn't prepare any of that in our sample here. You'll see in just inject SSR. That's because that's coming from JavaScript. And then Elide has taken care of embedding our props here as JSON so that they can be loaded on the front end and provided to the front end script. The props have to align perfectly so that when you rehydrate that at the front end, it follows the same render steps. Elide's taking care of making sure that serializes to JSON, embeds somewhere safe in the page, and is loaded in our front-end script and made available to the render. This can actually get pretty complex. So our website, which is elide.dev, is actually this exact same model. It's implemented in React using a framework called MUI, which is a very popular UI framework in React. And this is something installed right off the shelf from NPM and used in a polyglot hybrid server. And as you can see, it's pretty fast. Right here, I'll go back to Google so you can kind of. And that's a server-side render. So that was very fast for a response. But then from there, now we're on client side, right? And so browsing is also very, very fast. And so you get an amazing application experience, still with Java and Kotlin, all the language stuff that you love, all the standard library stuff that you love, but with JavaScript strapped onto the side in a very, very, very fast VM. And here's the view source. Let's take a look at that. Okay, so you can see that Elide served our CSS, right? It rendered the JavaScript into CSS and HTML. And then it passed in the props, which got rendered in, and it took all of that and spliced it into the body. But let's explore for a second what that means, right? Like if you have this sidecar JavaScript VM ready to go, strapped to your app, and you can run JavaScript in it whenever you want to, it sort of changes the rules of what we can now do. Yeah, so I had one slide here in terms of the front end being served as well as the back end. So, number one, Polyglot multiplies APIs. This is part of the problem because if you're using JavaScript together with Java or Java together with Python, both of these languages have a way to pull environment variables. They have a way to log. They have a way to write to disk, right? And so you need all those APIs to work in concert as if they're just one thing. Part of what Elide does is it brings you tools for that. So as an example, our engine provides universal .env support. So you can have a .env file and you can access that in any of these languages. And we're doing kind of the work under the hood in GraalVM to insert those variables into your guest VM. Seems like a simple feature, but you expect an environment variable to exist like this in Node. It should exist everywhere. Efficient deployment. When you go to take your application into production, you don't want to have a 5 GB image if you can avoid it, because
That's going to increase your startup time, your download time, your storage space, your cost. The more efficient and trimmed down and tailored to the purpose your production assets are, the better. The way that we handle that is with native containers. So the container that you just saw running, for instance, was one of these containers. And in this case, we have a JVM Kotlin app working with a JavaScript VM right there, all compiled natively into one binary. And that binary doesn't actually have a JVM or a node installed. And the great thing about that is you have this binary just for your app, you run it, and that listens, and that's that. You no longer need to package the whole runtime in your image, which saves space, saves download time, and saves startup time. Next is application telemetry. You need logging, you need tracing, you need error reporting. Languages all have different ways to solve this problem. In fact, you kind of only have two choices. You can use something like OpenTelemetry, in which case you're going to have an SDK for each one of those languages, or you could use the language native logs, but in that case, you're again going to have multiple logs because each language thinks it's the only one in play. What we do for that is we give you a universal layer for telemetry where the runtime can actually emit OpenTelemetry traffic for you. So you don't have to install an SDK. You're just doing console info, logging, whatever is familiar in that language, and that becomes OpenTelemetry traffic for you under the hood. And this is all, of course, optional. You don't have to use the OpenTelemetry features. You could have a log file, whatever makes sense. Another thing, surely, if you've got multiple languages, that's going to complicate debugging. How do you attach a debugger? How do you measure coverage? How do you profile your application? Well, luckily, GraalVM has done a lot of work in this area. They've provided some amazing tools that kind of help you see inside these guest VMs and debug them. Out of the box, we have support for the Chrome inspector, for the debug protocol in IntelliJ. We're working on a language server through their LSP module. All of these you get for free. You can debug your application in Chrome, whether it's in JavaScript or Python or Ruby, it doesn't matter. Next up is dependencies. And I kind of mentioned this at the outset that if you have NPM and a Kotlin app, then you have to pull dependencies from NPM, you have to pull them from Maven, you have to update both sets of dependencies. It's a nightmare, or even if not a nightmare, at least a headache. And we want to make that problem easier. We've built isolated IO, and this would let you install those dependencies in tarballs that sort of get layered and become the visible file system for your application. And we're calling this sort of a closed world IO assumption to match what GraalVM considers a closed world class assumption. You can read from these tarballs. You can also write to them, and it keeps those in memory, so your application can still write. But all of these writes and reads, there's something in between them. And at that layer, we have a chance to deny them if you want us to. We have a chance to record them. If you wanted to gather the inputs for a calculation of some kind or measure the IO that's happening for a program, this is a great way to do that. Application secrets. This is one of our favorites. Secrets are tough because what programmers want to do is put them in environment variables. It's easiest to access in your app, and that's a totally fair reason to do it. On the other hand, it's not secure because those are host environment variables. Now, if I have access to the server, I can see all your environment variables. Secret APIs and SDKs, also not a full solution because we all know why secret storage is cheap on Google and Amazon. It locks us in. More power to them. It's a great service. Our issue with that, though, is that there should be a third way. You shouldn't have to choose between a security vulnerability and tight coupling to a vendor. The answer in the middle is that Elide can provide your secrets as environment variables. These environment variables are only visible to your app. They don't exist on the host. You don't have any coupling to an SDK. This is kind of what we mean when we say a cloud-first runtime. Every application these days, it needs logging, it needs visibility, it needs secrets. Since those needs are non-unique, what would it look like if the runtime helped us more? One other cool thing that we can do, any data that is considered a secret like this won't actually get logged. You literally cannot emit that data. It looks like this on the right over here, where it is like a password. It's essentially redacted. And because we have the visibility into your app like this, and we can sort of let you mark areas of your data model that are sensitive, we can notice that at the VM layer and in the logging logic say, no, we're not going to output that sorry. This is a protection that as Java JVM people, we know, right, log4j was a huge event. And so being able to just neuter that capability is pretty powerful. One other thing I want to talk about here very quick is where we want to go with this, because this is a feature that's not quite done today. It is possible to do full stack HMR in our model, where you have your sources on disk you're developing during the day, and we open a WebSocket to your app. We watch those sources, and as they change, we can actually recompile them and hot patch them into the VM and trigger a browser reload. So this would give you, as a backend developer in Java or Python or Ruby, all of the trappings of a React developer, where they're sitting there working on their UI and they can just make a change, save, and they see it appear in their browser. That's always been a challenge as something to implement for more backend focused apps. And luckily, the Espresso team at GraalVM, shout out to them, they're amazing. So we'll see if we can get that going here soon.
Could you define HMR real quick?
Sure. Sorry, that's hot module reload. So that's a feature where, where you make a change in the UI or you make a change in Java, and you don't even need to reload your browser. The browser actually updates from a WebSocket, and so you can see the app change. Yeah.
Cool. Thank you.
Yep. So that brings us to the roadmap. Just a quick summary here of what of those are actually shipped and what of those are under construction. We've been hard at work for 2 years on this, and so lots of it is done, but we have a long way to go. In fact, I haven't actually gotten a haircut since we started. So if you see my picture on the event page, that's exactly how long it takes to build a runtime. There's some exciting things coming too, like WASM targeting. I know that the GraalVM team is working on that. We've partnered with Cloudflare on a number of the things that we're building to try and make Cloudflare workers and other kinds of runtimes like that a viable target for these languages. The real dream here is you have a full stack tool chain. It's polyglot. You can compile native when you want to. You can run on JVM when you want to. And then when you're ready, you ship that right up to something like Cloudflare workers or a Docker image. Those are all supported deployment targets. So we also want to take this upstream. Peter mentioned Spring. I was a big fan of Spring early in my career. I'm a big fan of Micronaut now, Ktor. We want to contribute some modules to these that help you do this SSR stuff. You don't have to adopt the runtime. This pulls down the language VM for you, which is now distributed through Maven, thanks to the change made by the GraalVM team recently. So we can actually install the language VM, install the intrinsics you need, and run your views for Micronaut through React just like you saw before. And you don't need to use our framework at all. You can stay in your language. We've also claimed the tool chains and intrinsics namespaces on NPM. Those are ours. And so we're going to be distributing these tools and these intrinsics that I've been describing through packages. So you could feasibly install a package for ESBuild or Webpack, and that would now be available to use in your multi-language environment. Lastly, I just want to show some benchmarks, and we haven't shown these publicly yet, so it's very exciting for us. I hope you guys like them. First up is general language benchmarks. I want to preface this by saying that this is definitely the GraalVM team's work on display. They are amazing. It's full of the smartest people I've ever met in my life, and they make this thing super fast. So we're very, very lucky to be building on top of a technology like that. But it's still worth mentioning because it is our engine. We can execute Ruby very, very fast. We can execute Python very, very fast. This isn't even surprising to JVM people. We know the intrinsic optimizations that we enjoy in the JVM. This is just applying all the luxury we're used to the rest of the programming universe. And then the one that I'm really excited to present today, as of last night or the night before, it was very recent, Elide can actually outperform Bun, Deno, and Node at React SSR. Now, this is important because it's sort of the benchmark of the JavaScript runtime space. Bun came out and they said, hey, we can do React SSR at 60,000 RPS. And everybody perked up and went, wow. And it's an incredible achievement. obviously very excited for their progress because it sort of opens the door to these new runtimes. When you take JavaScript and power it with Java's intrinsics, when you take the network layer in Node and essentially move it to Netty, this is what happens. You get 600,000 RPS instead of 8.5. So we can run multiple JavaScript VMs in threads, and we essentially load balance over those. And even on a single threaded basis, because we're using native transports in Netty and so on, we're able to outperform them by almost 10K RPS. Okay, how can you get involved? Please star us on GitHub, share it wide, give it a try. It's possible to report bugs from Elide. So if you just say Elide bug, then it'll take you through the process of reporting a bug to GitHub, which is pretty cool. Soon enough, it'll actually track the runtime bugs and let you report them automatically. So it's pretty great. We are definitely looking for contributors and ideas. Feedback, ideas, contributors, just time and attention really helps us refine the runtime and make it stable. It seems like anytime we run it somewhere new, we learn something. And sponsorship donations. So Elide is a company, yes, and we are making some products like a build cache called Buildless, which works for Maven and Bazel and Gradle, by the way. Check it out, less.build. But this is an open source effort. This is all MIT licensed, everything you saw today. And we don't have any plans to attach this to a cloud so that your KV storage suddenly costs money. Not calling out any names on that, but our plan here is your runtime is yours, and it should sort of meld itself to your needs in your application. That doesn't involve reaching into your wallet. There are other totally valid services like build caching that we can give you in exchange for money. There's a command here. It's a little long. We wanted to make it shorter, but we didn't quite land it. So you can also grab this command at elide.dev, our website. That will install it. You can check out our GitHub, our Discord. To join the Discord, you can just type Elide Discord. It's a command in the binary, or you can go to that URL. We hang out in there all day, and this is all we do. So I'm going to pause there. You can take questions, and I really want to know what everybody thinks.
Thank you, Sam. Could you back up 2 slides real quick to that benchmark thing? I assume RPS means renders per second?
Requests per second, yeah. So
requests per second, okay.
Yeah, this is a
cool.
full cycle HTTP render, right? So that includes URL parsing, invoking the like figuring out which of your guest code, where the handler is, dispatching that, buffering a response, sending it, right? And so it's a full cycle of a React render, yeah.
Right. Okay, cool. Wow, yeah, that is impressive. Anything about the hardware that this was done on is relevant or not, or is that just sort of details we don't need to worry about? Like,
so it definitely varies on the native transport layer, because on Mac we only have access to KQ versus Linux where we have access to ePOL and IOU ring, right? We support some of those new native protocols, and that's where a lot of this performance comes from, by the way. But yeah, the answer is that we see the same pattern across all operating systems, even if the numbers are a bit lower, right? It's definitely fastest on Linux. Yeah, does that answer your question? Sorry.
Yeah, totally. Yeah, and I mean, Netty's pretty amazing. I remember when Spring Boot started offering Netty support, I was like, oh! Yeah, it was pretty crazy. Cool.
Right.
Yeah, folks. So feel free to ask questions. Pretty cool that first time sort of seeing the market. What have developers, Node developers that you've talked to, have had to say about it? I'm just curious. Run screaming the opposite direction, casual interest. I mean.
Hold on one second. I was adjusting my screen so I could see everybody. Node developers, the first thing they usually tell me is like a joke about the JVM and how many lines it takes to write a hello world. And I tolerate that. And then I talk to them about like, okay, Java is seeing a lot of like new stuff, right? We see virtual threads, we see syntax changes, records, pattern matching. And most of the developers we talk to outside the JVM community don't know about any of that yet, right? And so they're not aware that like virtual threads are crazy fast, and we can actually use those in GraalVM now. So soon enough here, we may see Panama and Loom make it into Elide. That just brings those benefits into Python and Ruby and JavaScript too. So
Yep.
Mhm.
Wow. Cool. Yeah. That's pretty amazing. Cool.
Oh,
All
here
right.
we
We
go.
got a couple questions there. Can you see that, Sam, or do you want me to read it back to you?
I can see it. Yeah. So,
Cool.
so Saeed asked, how many contributors are working on the project? The answer is 3. Really, it's Dario who's in the meeting here, and it's me and a contributor in Australia named Damien. Big shout out, by the way, to Dario, who is my partner in crime in the code, and thanks to him for fixing many of the bugs this week. And then, yes, the presentation slides will definitely be shared. All of this is open, and so we'll get that up. And yes, it is a priority to update the README in the website. We find that people, when they find this framework, they kind of see it as like a Spring or a Micronaut, and they discard it. They're like, okay, this is a Micronaut-like thing, and I already like my framework, right? And so we are working on re-explaining this runtime because that doesn't capture the full power and flexibility of what this can do. You can use this with Spring if you want to, right? And we even want to ship modules for that. So yes, definitely in the next week, maybe even sooner, we're going to have tons of website updates, release pushed, right? And so all of that will change. Yeah. So I think that answers your questions, right? Oh, and then yeah, Felipe mentioned it supports multi-threading. That's true. So Gradle VM thankfully lets you spawn threads in Python and Ruby and so forth, and so you can do that in Elide as well. We actually use the Netty event loop between languages, right? So when you're executing a task in JavaScript or Java or Python or whatever, it's all sharing one event loop, which is one of the reasons why it's so fast. Cool. Any other questions? I'm sure you guys will have bugs, if not questions.
Yeah, no, I think you covered that on one of the other slides, like how to file bugs. I thought it was kind of was that one of the features built into the CLI tool? Did I see that right?
Yeah,
Into the
that's right.
binary?
And we actually want to make that a user level feature. So for example, maybe at the runtime layer, we notice an uncaught exception, we can report it to Sentry for you. The runtime could easily be doing some of those, even just over OpenTelemetry. So we applied that feature to us first so we can hopefully get a bit more stable, yeah. But yeah,
Sweet.
you can type Elide bug and it walks you through. Cool. Well, look, guys, this has been 2 years in the works, and we are just so thankful that engineers will see it and think about it at all. And so I just want to thank everybody who came today. I mean, big moment for us for sure.
Absolutely. Yeah, excited to have you here. Thank you. Yeah, maybe Sam, we can follow up with something in a couple months. Maybe we could talk to the Gradle VM team a little bit, see if they want to join you. That could be kind of fun, right? It's like a combo presentation with
Sure.
them, sort of thing. That could be kind of interesting. So I would love to have you back. I think there's, I think there's clearly some interest. So let's keep in touch and make sure to have you come back in a couple months and give an update because sounds like you and Dario and others are shipping features fast. So congratulations on that. And yeah, those are pretty impressive looking performance numbers for sure. I think you'll get some questions on those, right? Exactly like how did that happen?
Yep.
So be prepared for that. But yeah, this looks great.
We have run the benchmarks literally hundreds of times because we did not believe it ourselves. And one thing I can kind of close out to show you guys is what a pure JavaScript app looks like in this model very quick. And this was kind of one of the ways that we exercised our API compatibility with JavaScript to really test it, right? What that means. So what you see in front of you is an Express app, purely conventional JavaScript Express app. It requires Express. It sets up a couple of handlers and it listens on a port. Now, this test script actually runs unchanged on Elide, byte for byte, and that's because we provide a sort of mock Express layer that's powered by Netty. And so the same code can be dispatched just like any other Express code, but it's happening all under the hood through Netty. This is one of the benchmarks that we used. And so we see this benchmark, like this exact script, perform at about 10K RPS on Node. But on Elide, that immediately goes up to 500k RPS. And that's partly because on a single threaded basis, Java is faster. And it's also because, of course, we can stand up multiple VMs and load balance across them, which you might argue is cheating, but Node doesn't have multi-threading, and we do in the JVM. So really what I want people to take away from this is that it's time to love the JVM again, and it will rescue us from all of these language problems that we see, even in Python and JavaScript.
Well, yeah, and then you throw like a cloud full of containerized JVMs at it, and you don't really have a lot of limits on scaling. When you and I were talking about this over email and setting it up, one of the other things I remember we discussed was like, Node.js sort of API compatibility and sort of the surface area of that. And if I recall correctly, you said it was like you're kind of going after that 80-20 rule for the time being. It's like, all right, let's focus on the 80% of the common APIs, and we'll chase down the last 20% of the corner cases, less frequent ones. Is that, is it too early to say, is that what your goal is in terms of Node API compat, or is it like, TBD, we'll find out when we get some feedback, from developers, or do you kind of already have an intent on that?
So we're members of Winter CG, and that's kind of the goal of this operating group, because it's a great question. And JavaScript APIs, especially at the runtime layer, you think of deno, bun, and workers all kind of pushing that space forward. This is where we all meet and decide what our baseline is going to be. We're going to support the Winter CG baseline standard, which means any code that's written to that can run on Cloudflare workers, it can run on deno, it can run on Elide. We're already members. We're obviously the smallest, newest members, but very excited to deliver compatibility with that soon.
Heard it here first, folks. Yeah, no, I think this is pretty cool.
Thank you, everybody. And look, we're all on Discord, so come hang out with us. We'll do another couple of these presentations. We're going to be at Python and Ruby groups too. We'll see. I mean, honestly, JVM is closest to my heart, so this is my favorite of all of them. But we'll see what everybody says, and please reach out. We're open and looking for contributors. So thank you, everybody, for your time.
Absolutely, yeah, getting some love there in the Zoom chat. Thanks, folks. And do you have so Discord's the best way to get in touch with you? I think in summary, right? That was the takeaway. Right. Like not okay, very good.
Elide.dev/Discord should actually put you right into our Discord through an invite. It's pretty cool. And yeah, like any bugs, any features, any ideas, requests, we're open all of them for sure. Thank you, guys.
Sweet. All right, looking forward to having you back.